poison.
Snow is not poison. I know that. It's not that they shut down Denver. They said you just shouldn't really drive for a couple days.
I like snow when it's on the other side of the
All right. The only ones I have are right behind Isaiah. It's those white ones. Yeah. Disney, when he wears those ones, he like stretches out the strings, like pulls them. Yeah, like you would with a hairband.
Weirdo.
Those ones. Yeah, they're the ones that are obnoxious. Your only other choice would be to go down to the office. I think they have more of those ones. Okay. Oh my gosh. Oh my gosh. It has been a day. I've already got so many steps in. Okay, so. I just feel my neck still like sweaty when I get home, so I'm just like ripping my mask off.
I get home, mom's like, "Let me throw the mask on." I'm like, "Oh, it's still on?" We wear these all day, every day. We're gonna get used to them.
Yeah, I'm still not, but.
The only time I can't stand wearing masks is when I'm exercising.
No, yeah.
Because then my upper lips are, they feel like it's sweating.
I just hate how you have to wear a sweaty mask. Like even the sports teams, you have to wear the mask while playing, and it's like, how does that not get gross and sweaty?
Exactly.
All right. So we left off yesterday talking about yes, you know, the day before yesterday, you know. Hold on, I'm gonna go back. Talking about energy footprint alone, and so. Oh, please. Hey, look who it is. How are you, man? Yeah. Yeah. All right. Talking about how CO2 from fossil fuels is our largest use of energy, which affects our carbon footprint, which affects our
The slide didn't change? Oh, there it is.
Yeah, I was putting it back. I just went backwards a little bit. All right. So developed versus developing countries. So there's a correlation between average income and ecological footprint. We looked at that in some of the graphs that we saw yesterday, or the day before yesterday, Jesus. Last class period, whatever. And so there is sort of that we as America or the US have a large average income compared to a lot of the rest of the world, and we also have a larger ecological footprint because we have the money to buy up those resources and expend and be frivolous and things like that. Usually developing countries have smaller ecological footprints, which is a really interesting thing when you consider the Paris Accords that have been going on, that Trump pulled us out of and Biden put us back in, because that makes the US pay for other countries' ecological footprints that are developing countries, even though they already have smaller ecological footprints than we do. What? No.
Yeah. I'm trying to see somebody.
No. You're weird.
Exactly. Stop doing
Boy. All right. So why do developed countries have a larger footprint, like the U.S. or the UK? Food, which is a big part of the ecological footprint, not just how do I want to say it? Not just in consumption, but how much land and resources are required to grow that food. Meat-rich diets tend to be more popular in higher economic countries versus a grain diet. And the grain diet is much less taxing on the environment than a meat diet. Another one is the energy, the fossil fuel dependence of carbon dioxide emissions, that we have a lot more people like driving in the US versus like something like Madagascar. Fossil fuel dependence is also twice the energy of a diet, so whether that's meat or grain. Lots of the farm strategies, automobiles, factories. So farms also not only fall under food, but they fall under energy because the amount of stuff, whether it's the tractors and fossil fuels or the CAFOs, the CAFOs, and the machinery required for those. And then we also require more of a carbon dioxide fixation with that. So if you guys remember all the way back from, what was it? I think October, when we discussed things like the nitrogen, carbon, water, phosphorus cycles, we need a lot more nitrogen fixate or carbon dioxide fixation. Sorry. Oh, and I forgot biome on there.
When did the packets due?
I was just answering that, probably right before spring break. Get through them, hopefully. One of the things too with carbon dioxide fixation is we talked a while earlier when we talked about biomes and the coral reefs and how our water is becoming more acidic. So part of that reason is because if you've ever taken a chem class and you've talked about equilibrium, we're putting more carbon dioxide into the air, and our nature, our environments are always trying to find that equilibrium. So when you're pumping mass amounts of carbon dioxide into the air, the water is going to actually absorb some of that. And absorbing carbon dioxide into water will make that more acidic. So that's kind of where some of that comes from. Most of you would have had bio last year, and we didn't get to do the cellular respiration lab. So sad. Yeah.
I did right before that.
The one we do one where you like breathe into a tube and it turns colors.
Yeah, I did right before
Yeah.
that.
So, well, his class didn't get to do labs because they're annoying.
You know you love them.
I loved a very select few of you.
And I was one of them, wasn't I?
Maybe, maybe not. All right, ecological footprint per person. So again, high income countries, we have a much higher ecological footprint with especially the energy and the food resources used. Middle and low income countries. So that is your difference. Next week, I will actually have you guys, what is it called? Let me close out of this, your own calculation of your eco footprint. So be aware, I just have to make sure the website still works. There we go. Sustainability. Yeah. There's 3 of them around this room. There's one by Devon that's not being used. If you need more, I can do that. You know, unplug it and replug it in. All right, so sustainability. This is definitely going to be the bigger theme throughout the rest of the semester. It's just human use of resources. We have to use these resources. There's no like going 100% like just cold turkey with all of our resources, but using them without depleting them in order for future generations to have that. We'll definitely talk about that a little more next unit with like fossil fuels specifically, and how quickly they are running out. And so things like the XL pipeline, that we've seen some videos on and stuff, how that impacts sustainability. So
This got me thinking. In an Infinity War, Thanos must have cut the entire universe population in half.
Yep.
Because we're using up too many resources.
Correct.
Why didn't he have a smarter idea and say, refill all the resources and make them infinite?
Probably because killing people is easier than creating infinite resources. That is true. I totally agree with that. That's a valid point. Marvel went totally wrong there. All right. So we have a core set of global indicators, and don't worry, we'll go through each of the 5 individually, but just kind of so you can get an idea of what are some of the things we look at as a whole. Is energy supply, renewable energy, emissions from carbon dioxide, whether it's per capita versus total. Glacier mass is a huge thing that we look at in terms of albedo, and climate change. So a lot of your climate change doesn't actually come from, what do I want to say? It's a positive feedback cycle at this point. It's starting to spiral out of control. No matter how much less carbon dioxide we kind of put into the air, and that's because of the glaciers. Biodiversity, ozone, forest, freshwater and saltwater, and then just government and management in general, we're going to kind of look at too. All right, so the first one in the table in your notes is biological diversity. Yeah, no, you didn't have to write anything for that slide. We've had many extinctions. We've had 5 mass extinctions, but we've had a lot of little ones in between. Extinctions are going to continue. Most biologists do consider that we are currently in the middle of a 6th mass extinction. Yeah. Your indicator is biological diversity. Your extinction rate is increasing. Outlook for the future, extinctions will continue. Yep. So they do consider us in that 6th mass extinction, and for a few reasons. One is that we do have species dying off and not being able to come back pretty much every day. We're getting some lower genetic diversity, which is gonna, did you guys make it to genetic diversity last year? I don't think so. Less genetic diversity there is, the more difficult it kind of becomes for the species to have healthy offspring. Same with humans. Oh, we never got to the blue people last year. So sad.
I'm pretty sure last year we ended up with one simulator with blue.
Oh, yeah. Okay. Yeah, we didn't get to the blue people. Troublesome.
The Smurfs.
Yeah, there's actual people in here in the U.S. with like blue skin, and it's because of inbreeding.
Actually, I thought that was because they ingested silver.
Nope, it's because of inbreeding. And then we have a big part of it too is the food chain, like how quickly are food chains collapsing, and as they collapse, it's harder and harder for other species that may have not originally been impacted to stay alive. All right, number 2 in your table is food production. Our recent trend is the per capita production is possibly leveling off, and we don't have a clear outlook of the future. We have a whole lot of projections, and they are all over the board. So we've talked about like GMOs and the ability to mass produce our food, but we're getting to a point where we're running out of space to do so. And if we don't have that space to continually grow, we can't overproduce our resources as far as food production.
So basically, what you're telling me is humans are killing the planet, it's all our fault, and we are the worst species that Earth has ever created, correct?
By choice, yes. All right. Number 3, average global surface temperature and carbon dioxide concentration. That is really long. It is obviously increasing, and with the more people, the more food, the more energy, that's going to continue to increase, at least in the short term. So that is some of the stuff you see, whether you believe it or not, like the carbon offset taxes, some things like that. People are trying to do, but it's literally just paying money because you use up carbon dioxide. It's, I don't know, a nice attempt at money gathering, I guess. Fundraising, we'll say it. That global trend is still an upwards continuance. I know it's hard to see these numbers, but this is basically the 1960s carbon dioxide emissions, and then more currently as of 2015. It does kind of cut off a little bit, and it's a good amount. Like it's 125-ish, 130% increase in the last 50 years. Number 4 is human population, which we've definitely talked a lot about, and you can see that human population curve that we've looked at many, many times, how the global population has stayed kind of steady, and then with medicine and farming and all these other things kind of all happening at the same time, our population just skyrockets. So we're still increasing. However, we are starting to level off. So we have a couple projections over here with a steady increase versus kind of hitting that maximum and then actually having a global decrease. So there's a couple different projections.
Did you ever watch that movie I told you about?
What was
What
it?
happened on Monday?
What was it? What happened on Monday?
What happened to Monday?
To Monday. I did not. Is it on Netflix or?
There's one in the company, that's the only company.
Okay. I'm writing it down because I will probably watch it this weekend.
It's very interesting.
All right, everyone good? No? Okay, sorry. All right. And our last one, number 5, is the resource depletion. That rapid depletion for many, not just the United States. Human ingenuity develops so-called new resources. Efficiency of this use is increasing in some cases. Our technology, we know we need new resources. We are trying to get them. You know, we're improving solar. Solar originally was not a very efficient, 20 years ago was not a very efficient resource, and they're improving the voltaic cells and the things like that in order for them to last longer and to keep more energy, because there's still no way to store it. So if you have really sunny days and you have excess energy being made by your solar panels, it just goes to waste. Same with hydropower, some hydropower. Another one I've seen, Greta Thunberg, as much as she is in the news, drives me freaking crazy because she's so young and naive and dumb, in my opinion. But she just put out, was she like 12 years old or something? She just put out a big thing about how we need to be using more batteries. Okay, that's fine. Rechargeable batteries, good thing, easy to do, like your cell phones. But the materials for that, especially a lot of it comes from mined places in like Africa, and those people are not treated very well. Think of like your sweatshops in a mining facility. Low pay, they die young, there's no safety precautions, things like that. So, okay, yeah, we want to make more batteries, but this is how we're treating the people mining for the minerals for those batteries. So it's just kind of we've got to figure that out. We've got to increase our technology. There's a lot of jobs in this field because of that. The third one? Yeah.
After this, can you go back to the second one?
Yep. Are you good, KK? Yeah. All right.
Yes,
Yeah.
What if we built like a giant drilling engine that uses the atmosphere temperature and the temperature in the earth and use that to power generators?
We'd have to get low enough in the earth to do so.
I mean, we
it's erupting lines
can
and
get 7 miles down. But, I mean, yeah, you know, in the short term, it won't be good. Long term, probably.
Yeah. Leland, you good? Okay. All right. Where did I just set my, oh, right here, in front of my face. So this is just kind of a map of some of the major environmental problems. We have a huge depletion, where's my mouse? There it is. Depletion of natural resources. Mexico, it's a huge water pollution issue. What is it? Biodiversity losses all through South America, and air pollution is there as well, because you have a lot of factories, just like you would over here. So those are kind of like some of the bigger issues worldwide. When I was talking about the water, finding clean water, I still can't remember what country it is. Over in Africa, one single bottle of water, your 12 ounces or whatever, cost more than a day's worth of work, because it's so hard to get. All right. MSY, or maximum sustainable yield, is the maximum amount of a resource that can be harvested without compromising the future availability of that resource. So how much can we harvest that it'll still be able to be replenished for future generations?
It's funny how like the older generations are kind of like old. They kind of say all the world's problems are currently because of the current generation. And if you really think about it, it's because of them. Instead of, you know, trying to keep our resources at a reasonable level and not overuse.
So that actually goes both ways. If you want to go energy use, like fossil fuels and stuff, I would agree with that statement. However, when it comes to the throwaway society, where you're not reusing or recycling things, it's definitely our younger generation's issue. So it goes both ways. We are very much like use it once, like paper towels, throw it away. Use it to where your older generations are going to be using things like rags for the same purpose, or towels. The what? Yes. Yeah. Did you get it? Okay. Yeah. The yellow part does. I'll wait for you.
I have to.
You have the picture? Okay. All right. We can figure it out, yeah. All right, so carrying capacity of the environment. We've actually seen this exact same graph before, very generalized, obviously. Over time, our population increases. Our maximal sustainable yield we have passed at this point. They usually consider it our carrying capacity divided by 2. So while we estimate carrying capacities, we can still estimate a maximum sustainable yield. Under logistical growth, an annual harvest, so logistical growth is where it was a little bit more steady. I'm trying to think of, I can see the picture in my mind, but I can't remember the term that goes along with it. I apologize, I'm fried. And then this would be, that kind of peak is what we would look at harvesting. So our annual growth, and then finding that part of the carrying capacity and being able to harvest for it, since we have seasons. This includes a little bit more in regards to, this one is for fishing. So you have your amount of biomass, your maximum yield that you can get. And then when you start overfishing, that's where you get your tragedy of the commons scenario, and then full on depletion. So your MSY, your maximum sustainable yield, is before you hit that overfishing point. All right, some issues with MSY is life histories and survivorship strategies. Survivorship is, we kind of did a little bit with the cemetery lab. Usually I have you guys take care of bubbles and have you guys do different strategies with taking care of those bubbles and see how long you can get them to live. So like parental care, things like that would go into the survivorship strategy. Birth and death rates, true carrying capacity of the system. Like I said, that's oftentimes an unknown. We have to estimate it because we don't know what it is until we've passed it. And then it also gets very political, which always screws everything up.
If you're trying to make us see how long we can make a bubble last, mine would be the
Yeah.
first.
So, you know, in a COVID year, blowing bubbles is very looked down upon. I'd give everyone, like, within their groups, you get a thing of bubbles and a hula hoop, and the hula hoop represents survival. And then it's how do you get those, you know, from a distance. You can, you know, stand below the bubble and like kind of keep it in the air. People take like books or paper, try to keep it up from dying or popping. But if you're too abrupt with your air currents and your movement, it does pop the bubble. So it's actually a lot of fun and a little messy, but not in a COVID year. There is ways to take care of bubbles.
That is very weird.
Yeah, it's a lot of fun. Need me to go back? Sorry, there you go. You're welcome. And the last little part, I'm just realizing it's in the wrong part of your pages, but that's probably just because Word sucks when it comes to formatting. It's just kind of a quote on what some of this means. So the concept of MSY often is seductive. It is defined as the greatest amount that can be taken from a self-generating wild population of animals after a year, while still maintaining a constant average size of the population. Or summed up by a biologist, P.A. Larkin in his keynote address to American Fisheries Society in 1976, it is an optimistic dogma that assumes that any species each year produces a harvestable surplus. And if you take that much and no more, you can go on getting it forever and ever. And so we kind of talked a little bit about this roundabout with the tragedy of the commons. If you were taking a little bit more than you needed, your whole group could not have a harvestable surplus, at least one that wouldn't put you into decline. And so that's assuming things go well for those species every year. Well, what happens when El Nino hits and destroys the fishing supply? That's something you can't even plan for, even if you are taking responsibility and only taking a sustainable amount. So that's why they call it like seductive and an ideal or optimistic dogma. It's not reality. All right. Last one for the day. This sucks because this is usually kind of a fun one to do. Actually, we might even get through some of it. All right, is urban runoff. If I could get it posted, maybe. There it goes. So urban runoff is a big deal whether or not you are close to an ocean. In here, in Colorado, our biggest thing, especially being a headwater state, whatever waters we pollute means it stays polluted down through New Mexico. What is it on the other side? I'm blanking. Utah, Nevada, all of that. So whatever water we pollute, every other state that gets access to the water downstream gets that polluted water as well. So, and then we've talked about, yes, poultry is chicken. We've also talked about impervious surfaces in the past, or how water is able to trickle through. A single city block generates 5 times more runoff than a woodland area of the same size, because it's able to absorb, kind of like nature's sponge, soak up that water and put it back and recharge things like aquifers or streams or rivers. When it's a city block, it doesn't make it through the concrete unless you have that really, really fancy concrete that now does let water through. Then it gets run off and picks up all those chemicals on the concrete, picks up any of the waste on the concrete, especially if you're in a city like San Francisco where people just poop on the sidewalks, picks all of that, puts it up into your water supply.
Ew.
Yeah, you know it's bad when the city has an app to report human feces on sidewalks.
Seriously?
Yeah, dead serious. And everybody needs to be like California, apparently, because it is what it is. All right, here's just kind of a visual image of that 5 times difference between a city block and a woodland forest. So in a city block, you're not getting that deep infiltration into the aquifers or the shallow into the rivers and creeks that you would normally get with a woodland or some sort of impervious or non-impervious surface. Another big part of it is the evapotranspiration. So the whether it's rain or snow or whatever sort of precipitation that's coming down, 30% of it goes back up into the atmosphere versus the 40% of it that will throughout the woodland forest. Some of that is because it gets sucked up into the trees and released through the stomata in their leaves. That's how they breathe. All right. In natural systems, the porous and varied terrain of natural landscapes like forests or wetlands and grasslands traps that rainwater and snowmelt and then allows them to filter slowly into the ground. Vegetation and soil allow efficient infiltration and percolation. I know it's kind of hard to see in this picture, but infiltration is just going into the soil. Percolation is when it gets down into the groundwater. Oops, I did not mean to do that. Everyone good? All right. So impervious or non-porous surfaces, like your concretes and things like that, prevent any of that rain or snow melt from infiltrating and percolating through the soils. So your roads, your parking lots, rooftops, basketball courts, parks, whatever it may be, those are all impervious surfaces. All right. The runoff concentrates and gathers speed as it travels through the sewers, and they're set up at angles specifically to drain it so they don't back up. Excessive volume and power as it empties into the stream, so it comes out quite strong. It erodes stream banks and damages streamside vegetation, wiping out some of the aquatic habitat. So you can kind of see that in both of these pictures where you have your stream bank that's fallen, and it has on this side as well.
So is that why they look like that? Also, why do they have those black pipes in there for?
So the black pipes are called culverts, and so anytime, I guarantee anytime, especially around here because of all the flash flooding, they're either black because there's some sort of like PVC plastic, or they're metal, or they're concrete. I've seen all three of them. And that allows the stuff from the sewers to feed all of that water back into a stream. So it's trying to bypass that infiltration and percolation step and just put it right back into the streams. And because of all of that that comes, makes it the faster, faster, more powerful, which breaks out the bottom of the areas. And they usually try and vegetate around it, which you can see right here. But a lot of times, especially after what looks like was probably a fresh build, you get a very poor root system because it's not developed yet and it doesn't hold it there. And it will dirty up your rivers and streams as well with sedimentation. Did that answer your question? Maybe.
Yeah.
So with that, you get the increased flooding during wet weather. So kind of takes a normal stream and ends up widening, not necessarily for the stream's benefit or the animals that try to get through it. Since they actually, you might get your gravel or bigger sediment buildups blocking parts of the streams and blocking the ability for those animals to move. And then the lower stream flows during drier weather, which is where it could dry up and block them. All right. That turned up really small on my screen. So pollutants carried by runoff, which I talked about a little bit already with the sediment, especially here in Colorado Springs, where they annoyingly use sand and gravel to like get the ice off the roads or increase traction, whatever. It's dumb. Oil, grease, and any sort of toxic chemicals from any of your motor vehicles, especially even that couple of drips as you fill up the gas tank in your car, anything like that, that all gets washed back into the stream. Any sort of pesticides or nutrients from lawns and gardens. What time is it? Hold on. Can you give me 10 minutes? Okay. And then bring your laptop over. Pesticides and nutrients from lawns and gardens. So anytime you're trying to make your lawns or gardens very pretty, that actually all gets run off into your streams. Any viruses, bacteria, or nutrients from pet waste or failing septic systems, which septic is a big thing out here as well. If you ever go hiking through, like, what is it, Cheyenne Canyon area over on the west side of town, you'll see there's signs on some of those hikes to not let your pets run through the creeks, because that it puts in their pet waste or anything that they might be carrying into the streams that could affect us as we begin to drink it. Any sort of road salts or antifreezes that get laid down for like the snowstorm that we're supposed to have this weekend. Heavy metals from roof shingles, motor vehicles, and other sources get put down into the sewage drains. Thermal pollution from dark impervious surfaces such as streets and rooftops also cause a lot of issues as well, and can increase your evapotranspiration, and is part of the albedo effect as well. Everyone good? Okay. You're welcome. Now you know how I feel every day, and why I look forward to Fridays. You're welcome. I do a lot. All right. So when we talk about mitigation, it's kind of a prevention strategy. It's to mitigate or to adjust for those impervious surfaces, or just adjust for the issue in general. And like I said, there's a really fancy pavement out there now that's very, very, very expensive, that is permeable. So that means the water can actually go through the pavement. It's a little bit, it is like a permeable membrane. Look at you go, Mr. Biology. And I'm actually going to pull up a quick little video of it because it's kind of cool. Not necessarily, because a lot of the, come on, why is my thing not working? Hold on, I might have to close out of this. So as far as the sweatshirts go, Mr. Disney and his wife had to order some more materials. They ran out, so they're waiting on that, to show up in order to finish them. So once I know, I promise I will let you. Okay. Look, it's only 2. I'll leave it small, so hopefully it doesn't freeze for everyone else.
Over the past few years, cities and suburbs have become larger and densely populated. Areas that used to be covered by vegetation have now been replaced by infrastructures, parking lots, streets, and sidewalks. The absence of these natural surfaces has greatly disrupted the natural cycle of water. The excessive use of impervious coverings has left cities with the challenge of managing increased runoff volumes, bank erosions, flooding, and the degradation of water quality. Today, these problems pose considerable risks to the sustainable development of cities and suburban areas. It's a serious matter that requires immediate attention and a viable solution. Permeable pavement is a simple and lasting solution that imitates the original hydrological characteristics of natural soils. Its primary function allows runoff water to percolate through its joints while
Just a
being
bunch of
filtered
rocks, though.
with aggregate prior to returning into the soil. This helps reduce the volume of rainwater runoff, thus reducing the strain on stormwater management systems. The reduced demand on stormwater systems helps avoid overloads, debris buildup, and potential flooding. Permeable pavement improves water quality and helps groundwater recharge. It also reduces the heat island effect and can be used where vegetation is not suitable. Permeable pavement can also be an integral part of the water management system. Its use can help decrease underwater infrastructures and retention basins, resulting in an overall reduction of costs. Permeable pavement allows an increase in lot usage and building opportunities in public and private development projects. This helps governments focus on reducing life cycle costs associated with wastewater management in their municipalities. Available in various sizes and colors, permeable pavement can complement any architectural design or concept. Permeable pavement has been extensively and successfully tested as a sustainable and cost-efficient alternative in a vast array of applications. Permeable pavement is the ideal solution for cities and communities faced with stormwater management problems. Contact us for more information.
But Miss P, what I
Yes.
see here is that it just goes right through. Doesn't that eventually like get soft or something and sink?
No, that's why it's so expensive. Is they put technology into it to make it so it's not soft and it's still as constructive and tough as regular concrete.
Okay.
Sound like you doubt me, which is totally
Well, no.
okay.
Well, no, because see, in Alcatraz, it was constantly moist there and this concrete got soft.
Yeah. And concrete does break down, obviously. This is like, I swear to God, the national capital for stupid potholes. But, and it, just like anything eventually will break down. But this is supposed to last just as long and be real tough as concrete. So that's a way they're trying to mitigate. And as it becomes more common, like, as it becomes more common, it'll get cheaper, just like electric cars. Like a stupid little tiny Toyota Prius that could barely work back in like 2000 was, $60,000. Nobody pays $60,000 for a Toyota Prius anymore because the technology's there now and it's been more mass produced and it's become a lot cheaper. So once that happens to things like this, it'll get less expensive as it gets used more.
Yeah, it's like Tesla. They used to be
Mhm.
almost
Yeah, well, Tesla got in trouble for another reason too, especially asking after people had already paid for their Teslas, asking for them to pay even more before they would give them to them.
like
Yeah, so they got a little something else. So planting trees and other vegetation is another way to mitigate because that helps with the infiltration of the water and soaking it up through the roots and the plants breathing it out through their stomata. And then the whole building up, not building out. So this would be like an example of Colorado Springs, even though it says Atlanta. And then this would be your dense, more compact city. Not necessarily like Denver, because Denver's really spread out too. But when I was talking to prevention and migration of runoff. Oh. Permeable pavement is that first one. planting trees, and then building up, not out. Yeah, sorry.
You know what would be cool if they could just like find some kind of build some kind of machine that'll pick up a building and stack it on top of another one.
Right? Like playing Legos as a kid. Um, so here's just kind of like your natural water cycle, your evaporation, transpiration, condensation, all of that stuff. When it becomes more urban, you get a lot less going back in, the infiltration and getting that lower groundwater flow to fill up the rivers. And then the idea is to become more sustainable with our urban environments, whether it's using things like vegetation throughout, or the permeable pavement, or whatever it may be, and using your zoning to put in those parks and those wetlands, and helping lessen the runoff. So here's just kind of a doing it right versus doing it wrong, which is probably really hard to read. You get a lot of your, I can't look at both screens at the same time, I'm special. You have your sewer drains, your impervious surfaces being able to be pervious, and then yours compared to your straight up roadways where everything gets flooded and eventually even breaks down that concrete, things like that. Not dumping things into like your car washing chemicals into your drains and all sorts. This is gravel versus cement because water can filter through gravel, and so on. And this is just kind of cool. They do this back home and a lot of other places where they decorate. Like here, you see a lot of decorated fire hydrants. Other places, you see a lot of decorated sewer drains. So, all right. So that is the end of the notes for today. I'm giving you guys time to work on your DOLs and stuff. If you didn't notice, because I've gotten this question in the chat too, and I was intentionally ignoring it. After multiple requests, I have unlocked all DOLs from 5.1 to 5.13, which we got to today, as well as the first progress check. Remember, there's 2 progress checks for this unit because it's so gigantic. They are open through Friday night. I think I put Saturday. I don't remember. Awesome. If you're done with them, you're done with them. But I'm giving you these last, 15 minutes of class? Yeah, 15 minutes of class to get them taken care of. Now you have no excuses.
I do have it.
Oh, God.
I'm lazy.
All right.
But no, I was not here any help. I can try.
Hey, that man might be smarter than you think.
Oh no, he's pretty much useless when it comes to
Oh,
science.
God.
When it comes to math, he's pretty helpful. Science.
So just to give you kind of an outlook for next week, we've got a couple more sections of this unit to go through. We'll have another progress check. And like I said, you'll be doing your own like eco footprint next week as well. Leland asked earlier for those of you that were got the at-home kits to do your projects. I'll pick those up eventually. I got to figure out my new schedule with the esports team because God knows I'm never getting home on time on a Thursday. So we'll figure it out, I promise. Just put it all in the bag and I will pick it up. Go to your dashboard. And go to, yeah. You're Maury, right? Okay. Your new face to me and with the mask. It's like really hard. Oh my god. Of course. Alright. Well, we'll ignore that for a second. In a new tab, go to Play VS. You can just Google it, so you don't have to type a whole bunch of stuff in. Oh, you put PS in VS. There we go. Okay. Seriously. Hold on. Maybe if we don't click on the Google ad version. Do you mind if I type on your laptop really quick? Alright. Just to speed it up a little. At least I'm not the only one with a slow computer. And remind me again, I know Rocket League and Madden, so we have a spot open for Madden if you're willing to sneak a thing. And Disney and I are buying Disney. Okay. Oh my god. I might log out and have you do it on my computer. Let's see. For those of you that are interested in March Mammal Madness,
This division contained an intriguing assortment of animals to confound our investigation. Were they using code names? Were they in disguise? And what was a red wolf doing here instead of the red division? We wanted answers. Join us as we tackle the case of the Trixie taxonomy. The Egyptian fruit bat landed on a tree in Zambia. It looked down and caught the gaze of a kinda baboon.